Welcome to Creative World. In this video, we will solve chapter 2 exercise problem number 2.101. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. Ohm's law will also be utilized while solving this problem. According to this law, voltage across any resistance R is equal to the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 2.101. Find the value of Vx in given below figure such that 5 ampere current source is supplying 60 watt of power. This is the circuit diagram of given problem. Inside this network, we have to find the value of this voltage source labeled as Vx. While one information is given in this scenario, power supplied through this constant current source is 60 watt. So without wasting time, let's proceed towards the solution. First of all, we will try to find out voltage across this 5 ampere current source because power supplied through this source is provided. And we know that the conventional formula of power is the product of voltage and current. If we know one quantity, we can calculate other quantity as well. In this case, we know the value of power and the value of current, so we can calculate from this equation. Voltage equation for this current source will be 60 watt divided by 5 ampere. So the value of voltage will be 12 volt. And polarity notation of this voltage will be positive terminal here and negative terminal here. Modify the network by indicating voltage across this constant current source with their polarity. This same voltage will be appearing across 2 ohm resistance as well. Voltage across this 2 ohm resistance will be equal to 5 volt because of parallel connection. We can apply Kirchoff's voltage law inside this closed loop to calculate voltage across this 4 ohm resistance because voltage across other two elements is known. For that purpose, we will assume the direction of current inside this loop is counterclockwise. And according to this assumed direction of current, polarity notation across this 4 ohm resistance is marked. Now write KVL equation for this closed loop. Start from here. Current entering terminal is positive, so voltage across this 4 ohm resistance will be taken with positive sign. Next, current entering terminal is positive, so voltage across this 2 ohm resistance, that is 5 volt, will be taken with positive sign. Next, current entering terminal is negative, so 12 volt will be taken with negative sign, and all of these will be equal to 0. Now subtract 5 volt from 12 volt, it will become minus 7 volt because larger value have minus sign along with it. Place this minus 7 volt on the other hand side of equal to calculate voltage across 4 ohm resistance, that will be equal to 7 volt. Modify the network by indicating voltage across this 4 ohm resistance. Now after getting the value of voltage across this resistance, we can calculate current through this resistance using Ohm's law. So equation of current for this resistance will be 7 volt divided by 4 ohm. It will become 1.75 ampere. Similarly, current through this resistance can also be calculated because voltage across this resistance is known. Current through this resistance will be equal to 12 volt divided by 2 ohm. It will become 6 ampere. Direction of current through this 4 ohm resistance will be right to left because in order to make this terminal positive, current should enter from this terminal. Similar case will be with this resistance. Current direction will be downward because in order to make this terminal positive, current should enter from this terminal and leave from this terminal. Modify the circuit diagram by indicating current through these branches with their directions. Now we will apply Kirchoff's current law on this node to calculate current through this branch. On this node, two currents are entering, one is 3 ampere and other one is 5 ampere. Both currents are entering towards this node, so both are taken with positive sign. While two currents are leaving, one is 1.7 ampere and other one is 6 ampere, and both are taken with negative sign. We are assuming current I is flowing through this branch and it is leaving from this node, so it will also be taken with negative sign. Now add 5 ampere and 3 ampere together, it will become 8 ampere, and addition of 1.75 ampere and 6 ampere will become minus 7.75 ampere. Now subtract 7.75 ampere from 8 ampere, it will become 0.25 ampere, and place this minus I on the other hand side of equal to calculate its value, that will become 0.25 ampere. Here the value of current I with positive sign is indicating that we have taken right direction of current through this branch. Now after calculating current through this branch, this same current will be flowing from these two resistances due to the series connection. Modify the circuit by indicating current through this branch with its direction. We are able to calculate voltage across these resistances because current through these resistances is known. So voltage across this 1 ohm resistance will be the product of 0.25 ampere and 1 ohm. It will become 0.25 volt. Same volt will be appearing across this 1 ohm resistance because of same resistance and same current. But the polarity of voltage across this resistance will be opposite to the polarity of voltage across this resistance, because in this case current is entering from this terminal and leaving from this terminal. So this terminal will be taken with positive sign and this terminal will be taken with negative sign. But here current is entering from upward to downward. Current entering terminal will be positive and current leaving terminal will be negative. Modify the circuit diagram by indicating voltage across these two resistances with their polarities. Now in order to calculate voltage Vx, we will apply Kirchoff's voltage law through this closed loop. For that purpose, we are assuming the direction of current in counterclockwise. So write KVL equation for this closed loop. Start from here. Current entering terminal is positive, so 0.25 volt is taken with positive sign. Next current entering terminal is negative, so Vx is taken with negative sign. Next current entering terminal is positive, so 0.25 volt is taken with positive sign, and at the end current entering terminal is negative, so 7 volt will be taken with negative sign. Now add these both voltage together, their sum will be equal to 0.5 volt, and subtract 0.5 volt from minus 7 volt, the answer will be minus 6.5 volt because larger value have minus sign along with it. Place this minus Vx on the other hand side of equal to calculate its value. So the value of Vx inside this network will be minus 6.5 volt. So this was exercise problem number 2.101. Thank you. See you again in next video.